The next test is important test. It is called the short circuit test. This test is called the short circuit test. So what are the main objective of this test is to find out copper losses. That means IESC square or I2 square into R02 or R01. And the second objective is to find out series branch parameters of an equivalent circuit. And the third one is we can calculate the percentage voltage regulation. Of a single phase transformer. Here this test is conducted at HV side and the LV side terminals are short circuited. Why? Because at HV side the rated current is less. At HV side. That is easily indicated by the ammeter. That's why this test is conducted at high voltage side. So by closing the DPST switch, vary the single phase auto transformer and see the ammeter reading. If it shows rated current on primary side, then note down the voltmeter reading and ammeter reading and the wattmeter reading. Why I am writing VSC, ISC and WSC? So we are conducting short circuit test, right? No, not like that. So E2 is equal to V2 plus I2 into Z2. Under short circuited condition, the terminal voltage V2 is equal to 0 and the E2 is required to meet the drop only. Suppose let us assume, yes, this one is 110 volts and V2 is 105 and 5 volts is the drop. This 105 is now it will become 0. Only 5 volts is enough to circulate the rated short circuited on the secondary side. So here is given as 220 by 110. So the ratio is doubled. Means 10 volts is enough to circulate the rated short circuit current on primary side. If it is a 2 kVA transformer, if I want to find out the current at HV side, so 2000 volt ampere divided by the primary side induced EMF 220, then I will get the 9.09 amperes. If this ammeter shows the 9.09 amperes, then note down the voltmeter reading and ammeter reading and wattmeter reading. So out of rated voltage is 220, but 10 volts we are applying, means its a fraction is very small. Approximately 4.5% of the rated voltage is applied. 5% of the rated voltage is applied. So there is very small. And Bmax, we know that Bmax is directly proportional to V divided by F. So Bmax is directly proportional to V divided by F. F we are applying at rated frequency, but the voltage is less than that of the V rated, and the Bmax is very small. That's why hysteresis losses and eddy current losses both are negligible. Now tell me, and the wattmeter indicates purely copper losses ISC square into R01, or that means the total resistance when referred to HV side. And the impedance is also calculated. ZSC is equal to VSC divided by SC. This is not a short circuit voltage. The voltage corresponding to secondary short circuited. The voltage value corresponding to secondary side short circuited. That is the meaning of the VSC. ZSC is equal to VSC by ISC. And from this I can calculate the RHV. So these are all parameters are HV side. ZHV and RHV is so ZSC. From this we are getting WSC by ISC square is equal to R01 by ISC square is equal to R01. Yes, this is R01 is equal to plus by ISC square. Z01 is calculated and X01 is also calculated. The second objective is over. We have calculated the series branch parameters of an equivalent circuit. Series branch parameters of an equivalent circuit. And one more, if you know these values, we can calculate the percentage voltage regulation. The percentage voltage regulation is equal to I2 into R02 cos phi 2 plus or minus I2 X02 sin phi 2 divided by E2 into 100. So what are the values we are getting? So either it may be R01, right? R01 means I1 into R01 divided by E1. So as we have discussed when voltage regulation came, I1 R1 by R01 by E1, that is the per unit resistance on primary side and secondary side will be same. Plus is for lagging power factor and minus is for leading power factor. So we can calculate the efficiency and regulation. We know, if we know the losses by conducting open circuit test, we can find out the iron losses. By conducting short circuit test, we can find out the copper losses or variable losses. So if you know the losses, we can find out the efficiency. So voltage regulation, as we already derived, so no load voltage minus full load voltage divided by no load voltage. So this is a transformer exact equivalent circuit. Yes, approximate equivalent circuit, not exact, because the no load branch is shifted nearer to the branch. So this is a phasor diagram under when it is a unity power factor, so when it is a lagging power factor, and when it is a leading power factor.